All right, so we're still in 3.1, 3.1, and we're going over this problem here. And we talked about last time, we talked about like the first set of differences. And because the first set of differences were different numbers, that meant it's not a linear function, right? And because the second set of differences, 2, 2, 2, 2, 2, this did denote a, this was the same exact numbers. So that qualified it to be a quadratic function, okay? So if now I want to write out what my quadratic function would actually be, then I can start working on that. So, okay, so let's move on to this next part. So it says, write the recursive and explicit functions for g of n and the accumulated total number of push-ups got completed by any given day. So we're talking about this column. Can you tell me about this column? How would you do that? And so if I was to do, if I was to write this recursively, notice here, all I'm doing is I'm adding the next odd number. See, odd number, odd number, odd number. I'm just adding that next odd number. That's what recursive means. So how would you actually write that out, Ms. Johnson? So let me show you. Let me show you here. 3. Okay, here we go. So the recursive function, there's two parts to your recursive function. Hold on a second. There's two parts. There's a starting point. Okay, there's a starting point, and then there's the rest of it. So here's your starting point. On day 1, I've only pushed up 3 times, okay? So f of 1 equals to 3. So the very first thing that you need to do whenever you're writing a recursive function is give me a starting point, okay? So the recursive function works like this. It'll tell me how to get to the next number based on the previous number, right? It's just going to add the next number. I'm just going to add the next number. I'm just going to add the next number, and so on and so forth and so forth. Okay. So then I say, okay, well, okay, how do I write that? So first I just want to write it in words. So to get to the next number, add the next odd number. So that's just in words. That's just in words. But how do you actually write the recursive function out? Well, you will learn this later, but odd numbers, the way you say odd numbers in the land of math is 2n plus 1. And I know it sounds really, really weird, but can you think about this with me really quick? So if you look at 2n, right? If you look at the number 2n, it's going to show up as soon as the computer works. If you look at 2n, that's an even number. Okay, so 2n is how we say even number. Man, this is slow. There it goes. So the way you say an even number is just 2n. And so, Ms. Johnson, how do you know that that's true? Well, like, think about that with me. Give me a number in the chat. Yeah. Okay, so someone says 3, Ms. Johnson. And I'm like, okay, well, what's 2 times 3? And they say 6. See how that's an even number? And I'm like, oh, so no matter what, this is always going to be an even number. By definition, right? Even means you can divide it by 2. And do you see how there's a 2 right there? Right? Okay. And the next little part is this. And they say, hey, Ms. Johnson, what about 2n plus 1? Why is this an odd number? Well, this is an odd number because if you know about even numbers, the number right after an even number will always be an odd number, right? An odd number. So this is how you say odd numbers. So the way I'd write this here, and it's going to look really confusing because, you know, recursive functions were a long time ago. Okay. So let me just translate this to English. This is the next number. This is previous. This is odd. Okay. So this means next, the next number. This means the guy in front of him. And then this guy means odd. So that's a recursive function. I'll throw some of the videos that I've done for integrated one into here because they talk a lot about recursive functions, just so you have that remembering in your head. And even if you didn't learn it, it's not going to impede your learning for this class, so don't worry. Okay, but how would you write the explicit term? Okay, so the explicit term is a little bit different. So whenever I write explicit terms, I always change my my table, and I rewrite my table so it's a little bit more like helpful. So I write my 8 as 3 plus 5, right? And then I write my 15, and this is what one of your classmates said a while ago, is it's 3 plus 5 plus 7, right? Which again, kind of doesn't help me. So then I'm like, okay, well, I need to know that this is a quadratic. So because it's a quadratic, I know that it's going to look like this. It's going to look like n squared. It's going to have a squared in it. So then I'm going to play around with my numbers until I get what I want. So I'm like, oh, okay, so this one would be 1 squared. So I say, okay, let me try it this way. 1 squared. Okay. But 1 squared is 1. How do I get to 3? What would I need to do to get to 3 from 1? What would I need to do to 1 to get to 3? Yeah, I'd add 2. Perfect. Okay, cool. So then let's try the next one. So here I do 2 squared because that's what I'm doing. So what's 2 squared, y'all? Yeah, it's 4. It's not showing you, but I wrote a 2 squared there, I promise. So how do I get from 4 to 8 then? How would I get from 4 to 8? Oh, you want me to add 4? Okay, I'll add 4. Oh man, I'm not adding the same number. Okay, but I do kind of see a pattern. Do you guys all see my pattern right here? You guys all see the pattern that's going to happen right here? I don't know. Hopefully, I'm crossing my fingers. I really want this to be a good pattern. Okay, let's try the next one. So what would I write on this line here? I'm just playing with the pattern. What would I write on this line here? So this is 1 squared plus 2. This is 2 squared plus 4. Yeah, I'd put 3 squared. And I'd be like, all right, 3 squared. 3 squared is 9. Plus what gives me 15? Plus 6. Is it the pattern? Do you guys all see my pattern? Yes. What are these numbers called? Yeah, these are all even. So sweet Miss Johnson, you already told me how to write even numbers. How do I write even numbers? How do I write even numbers? In math. Yes. You're all translating. Okay, so Miss Johnson. So instead of writing 2, 4, 6 here, you want me to write 2 times n? Yeah, kind of, right? So I'm just going to write it really like awkwardly over here. This would be 2 times 1, right? This would be 2 times 2. You guys all see my little writing right here? This guy would be 2 times what? 2 times 3. Okay, my hope. Now I'm going to write this next one. I'm going to write this in terms of 4. What would I write here? What would I write here? Definitely 4 squared plus 2 times 4. That's what I'm hoping. I'm hoping that this 4 squared, which is 16, plus 2 times 4, so 16 plus 8, it's 24, y'all. It's 24. So again, I'm going to check my rule again with the next line. What would I write this in terms of 5? How would I write this in terms of 5? So what you're looking for, friends, if you don't know, you're looking for what is changing, what is staying the same. So I notice this squared is staying the same. I also notice this 2 times is staying the same. And then I notice this number here, 1, 2, 3, 4, it's changing, but it's also changing together with my number of days. You guys all see that? So then, can you risk this? Risk it. Be wrong. Be wrong to everybody. Who cares? What would my function then be? What would my function then be? And be wrong. Who cares? Who cares if you're wrong? Just be wrong out loud. Because then if you're wrong out loud, then you're going to be wrong here. So I want it to be based on n, y'all. So I want this n. Oh man, Ashley says, Miss Johnson, n squared plus 2n. And I say, I don't know. Let me see. So that squared stays the same. Squared, 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 squared. She hit it on the nail, right? Squared. Yeah. Okay. The 2 times, 2 times, 2 times, 2 times, 2 times, 2 times. Yeah, that's pretty right? So she's got both of these parts correct. Where'd she get this n though? Where'd she get this n? I don't understand. Oh, the number of days. So you're saying put that there and there? And the answer is yes. Very, very strong work. Okay, so now I know how to write in explicit form. Now, Ms. Johnson, you just started playing with the numbers. Yes, that's what math is. It's start with what you have. Hey, you told me this is a quadratic, so it had to be squared. Yes. So then I put 1 squared here. I got the 1 and I squared it. And I said, it's not 3. What do I do? And someone said, add 2, Miss Johnson. And I was like, all right, that's cool. 1 squared plus 2 makes 3. I can't tell the pattern from this. I need to look at more of the pattern in order to do that. So then we did the second day, the third day, and then we're like, wait. I see the pattern. We looked at what stays the same and what changes. So that's how we built this. Okay.